So this unit is called Quadratic Relations, and it's really a discussion about quadratic expressions. We're going to learn how to graph them, how to analyze them, and basically learn how to solve problems using these quadratic expressions. But before we do that, we need a little bit of prerequisite knowledge. So let's start off with the basics. So given any relation, the x represents what we call the dependent variable. Sorry, the independent variable. Independent variable. When it's graphed, it's going to be on the horizontal axis. Now, if you look down below at the graph down here, that means that the x-axis is our independent variable. Our y-axis, this represents the dependent variable, so it depends on x. So as x changes, what happens to y? That's basically how we deal with this. As x changes, it's the independent variable. What happens to y? So y is dependent on x. Okay? And now this one is graphed on the vertical axis. Now if you're fuzzy between horizontal and vertical, horizontal goes left to right and vertical goes up and down. Okay? So a lot of times what we'll use to graph these things is just a simple table of values. Now we learned a lot of different strategies a few units ago, but a table of values was the first one we learned. So a table of values can be used to produce a graph of any relation, as long as we have an expression for it. Okay, so we're going to do a bit of review on this. Remember, you learned this term a long time ago, this term, the first differences. Now, what the first differences are is really the difference between one y value to the next y value. How much does it change? And then the difference between that y value and the one following that. So this is called the first difference. And if it is a linear relation, which means is it a straight line, if that's the case, then each first difference value is constant, meaning they're all the same. Let's do an example to demonstrate this. So imagine we have the following linear relation here. Y is equal to x minus 1. Now, if we have all of our x components, this is our independent variable, we got to calculate our y values by substituting each x into the y, or sorry, in for x in the original equation. So, for example, if I put negative 5 in here, negative 5 minus 1, that gives me negative 6. I'm going to do the next one, negative 4. Negative 4 minus 1, that gives me negative 5. So I can now calculate the first difference between those two. So I subtract the current y value from the previous, oh my goodness, I apologize. I subtract the previous y value from the current y value. This will give me the difference between those y values. We call this the first differences. So the current one subtract the previous one. Current one subtract the previous one. Now when you do this, you're going to keep going. You're going to end up with this number as it changes. You're going to end up with negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. Now, if we do this math, we go one at a time. So, the current one, subtract the previous one. Negative 4, subtract negative 5. That's the same thing as saying negative 4 plus 5. That gives us 1. And as we keep going, you should be trying to do this as mental math. Negative 3, subtract negative 4. That's also going to give us 1. And if we keep going, what we're going to find is that all of these values come out to be a 1. So what we can see here is that the first differences column, every single first difference is constant. So that tells us that this is a linear relation. Of course, we could have just looked at the equation and said, hey, I recognize that equation. That's a y is equal to mx plus b equation. I know that's a line, but that's not really the point here. Okay, so when we want to graph this, we now just go one at a time. So each row is a coordinate on our graph. So negative 5, negative 6. So we go negative 5 over, negative 6 down, and we end up right here. And then we have negative 4, negative 5 right here. Negative 3, negative 4, negative 2, negative 3. We can see how this line is just keeps progressing over and over. We have quite a few points on it this time. Now we got to try and graph this in a straight line the best we can. Again, I don't have a ruler on here, so I'm just going to do the best I can. Whenever we are graphing, we want to fully label our graph. So that means put your X and Y axis on here and label the actual line or curve, whatever it is at this point. So in this case, Y is equal to X minus 1. So since the first differences are constant, we can say that the relation is linear. So the next follow-up questions are all going to be basically based on this information. So let's keep moving. We'll do a couple more examples so you can see how this changes. So let's move on. Let's do these two here. So we have the same idea. We have some relation, and we want to determine whether it's linear or not. And this we'll be able to know that once we've checked all the first differences. So in this example, we've been given a start on this. So let's try this out just to make sure this data is correct. If I have -5 and I substitute it in for x, what am I actually doing here? I'm saying y is equal to 1/2 multiplied by -5 plus 1. Well, that's the same thing as saying -5 over 2 plus 1, but if I want to add a fraction, I need to give a common denominator, so that's the same thing as plus 2 over 2. So this is -5 plus 2. That gives me -3 over 2. Right? Did I do that right? Oh, I think I'm looking at the wrong value here. Oops. No, that's right. -3 over 2. That's correct. -3 over 2, which is the same thing as saying -1.5. So our math still checks out. They're just writing it in decimal form here. So we're going to continue here. So we substitute -3. Try to do it in mental math. So -3 times 1/2, so it's -3 over 2 plus 1. So that's -3 plus 2, because it's going to be 2 over 2. -3 plus 2 over 2 is going to give us -1 over 2, or -0.5. Okay? And we're going to keep going like this, and you're going to end up with 0, and then 0.5, and then 1, 1.5, 2, 2.5, 3, and 3.5. Now when we do the subtraction here, we're going to subtract our current y value. We're going to take this y value and subtract the one before. So we have -0.5, subtract -1. That's going to give us a value of 0.5. And in fact, if we keep going this whole route, we're going to get 0.5 for every single value. Pause the video and try and fill it out yourself to make sure that you're actually getting those values. Do the math, get the practice. And again, we can see that our first differences are the same. So since the first differences are constant, we can say the relation is linear. Great. We can try and graph it as well. -5 all the way over here, and then -1.5, that's going to be down here. Right about there. -4, -1, -3, -0.5. We can see this is a pretty shallow line. We're just going to keep going here. I'm just filling in the values that we have here. Now we got to try and draw this line as straight as we can. Please use a ruler in your actual notes. Label our axes, x and y, and label the actual relation here. Y is equal to 1/2 x plus 1. Awesome. We got one left in this little topic here. Ooh, this one looks unique. Interesting. So we have y is equal to x squared minus 9. Let's try this out again. So if we sub -4 into for x, so it's -4 squared, that's 16. 16 minus 9, that's 7. Okay. -3 squared, that's 9. 9 minus 9, that's 0. -2 squared, that's 4. 4 minus 9 is -5. -1 squared, that's 1. Minus 9, that's going to be -8. 0 squared is 0 minus 9 is -9. And we continue on. 1 squared minus 9, so that's 1 minus 9. It's going to give me -8 again. Oh, I got the same number twice. Interesting. 2 squared is 4. 4 minus 9 is -5. Oh, I got that one again as well. Huh. 3 squared, That's 9. 9 minus 9 is 0. Well, we're getting a lot of repeated numbers here. And 4 squared, which is 16 minus 9, is going to be 7. Huh. All right, well, let's calculate our first differences. 0 minus 7, that gives us negative 7. Negative 5 minus 0, oh, that's negative 5. Negative 8 minus negative 5, that gives me negative 3. Well, this is unexpected, isn't it? If we keep going, we're going to get negative 1, 1, 3, 5, and 7. Well, let's graph it just to see what it looks like. So we have negative 4, 7. So negative 4 all the way up here, right there. Then we have negative 3, 0. Negative 3, and a y value of 0. So right here. Okay. And then we have negative 2, negative 5, all the way down here. And then negative 1, negative 8, right here. And then 0, negative 9. And then 1, negative 8. Oh, we're going back up. And then 2, 5. Or sorry, 2, negative 5. And then 3, 0. And 4, 7. Oh, that's not what we're used to at all. Well, let's draw the line. Do the best I can here. It's not the best in the world, but it'll do. Fill out our axes, x and y, and then put our curve or our equation here. Y is equal to x squared minus 9. That certainly doesn't look like a line to me. And in fact, if we look at our data over here, our first differences are not constant. So since the first differences are not constant, this means the relation is non-linear. More on that during the next lesson. So that's the basic knowledge that we need to have. We need to be able to create a table of values. We need to be able to create first differences. We need to know how to properly graph our equations. That means putting the actual points on there, drawing the expression, and drawing the relation, labeling our axes, and labeling the actual relation itself. All that information needs to be on there. And that's it for now. On the next one, we're going to learn about non-linear relations.